In this video, I'm going to introduce you to a process known as the mole method. The mole method is a set of calculations that allow you to move between mass of one substance in a balanced chemical equation or a reaction to any other mass in that reaction. To do this, you need the mass of the given substance. You have to know the molar mass of any chemical compounds you're interested in, and you have to be able to convert between moles of those different substances based on the chemical equation. So let's get started on this right away. Have a look at what's gonna be done. So first of all, you have to be able to determine number of moles given a mass, or determine the mass given a number of moles. And again, you've already done this. If, for example, I know the mass, I can determine number of moles. Number of moles equals mass divided by molar mass, and that's using molar mass as a conversion factor. Well, what if I'm given a number of moles and I want to find a mass? Well, I can do that as well. Mass equals number of moles times molar mass. And again, the molar mass is our conversion factor. So using the molar mass as a conversion factor is something you've done already. The other thing you have to be able to do, determine the number of moles of what substance, given the number of moles of a different substance in that reaction, in that chemical equation. And again, to do that, we use equation factors. So again, if we have a hypothetical number of moles of A is what we're looking for, we must have been given a number of moles of B, and we're going to multiply that by our equation factor. And remember, you get our equation factor from our chemical equation. And just setting up that factor, though, we are looking for a number of moles of A. So we're going to have some ratio of moles of A over a ratio of moles of B. And in that way, moles of B divide out, and we're left with what we're looking for, which is moles of A. And so those are the two processes you have to be able to carry out for the mole method. And you've done them already, so it's really not that difficult to get started on this. So here's a question. There's our balanced chemical equation. Lead plus sulfur yields lead 2 sulfide. If you look at it, it's balanced as written. 1 mole of lead, 1 mole of lead sulfide, 1 mole of sulfur, 1 mole of sulfur and lead 2 sulfide. So we can get started. So here's the question. If you have 50 grams of lead, so we're given a mass of lead, how much sulfur will be required to carry the above reaction? How much sulfur in grams? So the first step, mass to moles calculation. And so we have a mass of lead. So we're looking for number of moles of lead. Number of moles of lead equals mass divided by molar mass. Well, our mass was given as 50.0 grams. Our molar mass of lead is 207.20 grams per mole. Remember, 2 decimal places for molar masses. And when we plug that into our calculator, we get 0.241 moles of lead. So we've just determined the moles of our known, our moles of lead, based on a given mass of lead and the molar mass of lead. Next step, this is where we need our equation. We're going to convert between moles of lead and moles of sulfur, are unknown. And so again, moles of sulfur is what we're looking for. We're given a number of moles of lead. We just calculated 0.241 moles of lead, and we're going to multiply by that equation factor. And in this case, we want to be left with moles of sulfur, so it's in our numerator. We're trying to get rid of moles of lead, so it's in our denominator. Now we just go and put in the coefficients. Well, it's 1 and 1. So this is a 1-to-1 ratio, so that's really easy. You don't even need to calculate that. 0.241 moles of sulfur is left. Now, as I said, you don't really need to calculate that, so you can do that a little quicker if you prefer. If you recognize it as a 1-to-1 ratio, you can simply write out the number of moles of sulfur and just indicate that you realize it's a 1-to-1 ratio by writing brackets 1-to-1 ratio. And that would apply to any 1-to-1 ratio. Another example of 1-to-1 ratio, for example, would be 2-to-2. That's also 1-to-1. 3-to-3, anything like that. So if you recognize that it's a 1-to-1 ratio, you can simply write out the new number of moles, the number of moles of your unknown sulfur. And so the last step is a moles to mass, and this is a moles of our unknown, which was sulfur, to mass of our known, which is sulfur, and for that we need our molar mass of sulfur. And so mass of sulfur equals number of moles times molar mass of sulfur. Well, 0.241 moles of sulfur times the molar mass of sulfur, which is 32.07 grams per mole. And that equals 7.74 grams. 3 sig figs based on our original mass given in the question, which was 50.0 grams per mole. So that's the mole method. And so I showed you that in 3 steps. You can put this together if you want into 1 step. And so there's our balanced equation. And I'm going to introduce you another concept I like as well. And this is what I call labeling the equation. And so there's our balanced equation. And what information do we have? Well, if you went back to the question, you see we're given something about lead. We're given the mass of lead. And we're given, and once we know the mass, we realize we're going to have to calculate a molar mass. So we might as well include that. And I've labeled it. I've put mass and molar mass of lead with lead in my equation. Well, what else do we know? Well, we know we're looking for a mass of sulfur. And if we are looking for a mass of sulfur, we're going to need the molar mass of sulfur. So there I have included the molar mass. So this is labeling the equation. Now I'll have all the information I need in front of me, and I can just go ahead and put together a word or symbol equation, a substitution, and a solution. So again, what are we looking for? We're looking for a mass of sulfur. And what does that equal? Well, based on what we're given, we're going to use a mass of lead. We're going to divide that by the molar mass of lead. We're going to multiply that by an equation factor. And once we have that, we're going to multiply that by the molar mass of sulfur. And if you look at what we've done in these different steps, what we've done in this first step is we've determined the number of moles of lead. What we've done by multiplying that number of moles of lead by an equation factor, well, that's determining number of moles of sulfur. And then finally, when we multiply that number of moles of sulfur, we have determined the mass of sulfur. So 1 step, still need a word or symbol equation, but then you can follow it by substitution. 50.0 grams, 207.20 grams per mole, times the equation factor, 1 mole sulfur, 1 mole of lead, times molar mass of sulfur, 32.07 grams per mole. Looking at unit analysis, this is grams of lead, molar mass of lead. So the grams in that divide it. This is moles lead, there's moles lead. So those divide it. Moles sulfur, this is moles of sulfur. And so again, based on unit analysis, I know I'm right because that is grams of sulfur. So provided I put it into my calculator correctly, I know my answer is correct, which should come out to 7.74 grams, same as it was before. So 1 step, and don't forget about the labeling the equation, because that can be very useful. Okay, so here's another question. Hydrazine, N2H4, reacts with nitrogen or dinitrogen tetroxide, and in the process forms nitrogen gas and water. So the question is, if 50 grams of hydrazine reacts with excess dinitrogen tetroxide, what mass of nitrogen is formed? So before we go any further, we have to balance this. And to balance this, I'd start with the waters. Make that 4 to balance the oxygen here, 4O. Then you're going to balance the hydrogens. So if I make that 2 hydrazine, I end up balancing nitrogens. 4 plus 2 is 6. And, hydrogen, 2 times 4 is 8, there's 8. Now I balance the nitrogen, I have 6 nitrogen left, so now I have 6 nitrogens on the right, so that's balanced. And again, I can label my equation. I'm given a mass of hydrazine, 50.0 grams. I know the molar mass of hydrazine from calculation. The molar mass of hydrazine is 32.04 grams per mole. I'm looking for a mass of nitrogen. There's my question. And I know the molar mass of nitrogen is 28.02 grams per mole. So my equation's labeled. I know what I'm looking for. I know what I have. I have my given. So first step, number of moles of my known, my hydrazine, N2H4. Mass divided by molar mass, 50.0 grams over 32.04 grams per mole. Grams divide out, I'm left with 1.5605 moles of hydrazine. And so now I can calculate moles of my unknown, that's moles of nitrogen, and that equals that molar amount I just calculated, 5605 moles of hydrazine times the molar ratio, and I'm looking for nitrogen, and I have 3 moles N2 on top. I have 2 moles of hydrazine, again based on the ratios from the equations. Moles of hydrazine divide out, I'm left with moles of nitrogen, which is good because that's what I'm looking for, and I actually have 2.341 moles of nitrogen. So now I have moles of my unknown, and so the last step is mass of nitrogen, number of moles times molar mass. Well, I just calculated number of moles is 2.341 moles times the molar mass of nitrogen, 28.02 grams per mole, and that equals 65.6 grams of nitrogen. And so there is the answer. And so that, again, is the fairly straightforward process for going from a mass of an unknown, in this case hydrogen, to the mass of an unknown, in this case nitrogen, using your balanced equation, molar masses, and equation factors. That's called the mole method. And that concludes this video.